Biolog's OmniLog and PMM platforms provide an effective new approach to optimize bioprocess performance. To gain full value of this slideshow, first-time viewers are encouraged to watch the Technology Overview slideshow at the beginning of this series. As noted throughout the slideshows in this series, Biolog's platforms are versatile in serving multiple application areas. While this video emphasizes applications in bioprocess development, Biolog's platforms are also being applied to characterization, differentiation, aging, stability studies, cell line development, studies of mitochondrial function and chemical toxicology, in cancer research, metabolism and metabolic disorder studies, and studies involving genotype and phenotypes. In the context of bioprocessing, there are numerous distinct advantages to using Biolog's technology platform. As we will shortly see, the platform helps make bioprocess development simpler, faster, easier, cheaper, more efficient, and more scientific. It's broadly applicable, working for all cell types. You can use it to define the nutritional and metabolic properties of your cell of interest, as well as its range of growth environments and chemical sensitivities. It can also provide hundreds and thousands of culture conditions for bioprocess improvement, and the assays can be run kinetically. And finally, it's easily automated and can be expanded for high-throughput applications. Carbon and nitrogen substrates are key nutritional components affecting energy metabolism. Recognizing which substrates in these two important categories are preferred can help guide cell selection and media development. Biolog's PMM technology platform includes 4 96-well plates with 367 pre-arrayed carbon and nitrogen energy substrates. Positive and negative controls are included in each assay as a reference. As noted here, the substrates presented to the cells include sugars and starches, alcohols, carboxylic acids, fatty acids, amino acids, and dipeptides. Key to the power of Biolog's PMM platform is its ability to quickly and easily identify and measure the differences in substrate preferences between cell lines and types. This slide indicates the high metabolic activity and broader substrate preferences of the C3a liver cell line when compared to the A549 lung cell line. Biolog's automated OmniLog incubator reader is able to record metabolic rate activity by reading the assay plates in 15-minute intervals. Here, we see the results from one of Biolog's carbon substrate plates testing primary rat hepatocytes for a 3-hour period. This example shows the ability of Biolog's assays to determine the nitrogen substrates used by C3a liver cells. Biolog's redox dyes can be used to measure cell growth and death. As shown in this slide, there is a close linear relationship between cell number and reduced formazan dye. Biolog's dyes are superior to MTT, MTS, and Alamar blue dyes, which have been used in the past. To begin the determination of which energy substrates are most effective in promoting viability, Biolog's carbon and nitrogen substrate plates can be used together with cells that are in glucose-free media. This slide shows an example of one of Biolog's carbon substrate plates. By seeding cells into the plates and adding dyes on day 0, 1, 2, 3, and so on, one can observe different responses of cells to the nutrients provided. In the example shown here, glucose produced cell growth, while maltose maintained cell viability, and sorbitol and fucose brought about slow and fast cell death, respectively. The presence of serum and hormones in cell media can have important metabolic effects. Biolog's assays can quantify their specific effects on metabolism. Different serum batches and concentrations can also influence the degree of metabolism of various substrates. Such information can help guide both the selection of serum and substrates. Hormones are well-known metabolism effectors. Biolog's pre-arrayed hormone plates enable an easy way to assess the response of a cell line to 45 different hormones and hormone-like effectors. Here is a representative plate of pre-arrayed hormones and metabolic effectors. The results presented here indicate the influence of 3 different hormones at 6 different concentrations on 2 cell lines, the liver cell line C3a and the colon line 205. The colon cell line appears to be more responsive to insulin. Here, Biolog plates were used to verify the stimulation of CHO cell metabolism by insulin and to see if an alternative hormone could be found for use with these cells. As indicated here, however, no hormone substitute among those arrayed matched the effectiveness of insulin to induce a strong metabolic response. Biolog technology can also improve BioProcess by finding conditions to shorten doubling times and enhance productivity. The results presented here indicate that 10 energy substrates in Biolog's plates, when individually added to the culture medium RPMI 1640, helped to reduce cell doubling time. By assaying culture well's supernatant fluids with a simple ELISA assay, Biolog's plates were also successfully used to determine which substrates brought about an increase in MAB titers. The best of the 6 active agents yielded an increase in MAB titer of nearly 50%. As noted in this and the other slideshows in this series, cell metabolism lies at the core of many key application areas. Understanding this dimension of cellular behavior has important research and commercial value. Biolog's metabolic platforms stand alone in having the flexibility and capabilities to quickly and efficiently serve all these important areas. To discuss your specific application interests, or to explore setting up a trial evaluation of Biolog's phenotype microarray technology, or to place an order, please contact the following departments.